Here we are on Ethereum's website, ethereum.org. On the website, we find this tagline. Ethereum is the community-run technology powering the cryptocurrency Ether and thousands of decentralized applications. What does this mean? Ethereum is a network of computers all around the globe that work together to run apps, to run applications. Technically, you can run almost any type of application on the Ethereum system, but due to certain aspects of how Ethereum was designed, it's not necessarily that great for running all types of applications. What types of applications is Ethereum good for? Well, nowadays you'll typically find 3 types of applications that are run on the Ethereum ecosystem. The first type of application you'll find are applications related to money. The second are applications related to ownership. And the third are applications related to authenticity. People are very familiar with applications that get updates, they get bug fixes. Sometimes they get updates that break things, but most of the time they get updates that add features, and that's fantastic for most types of applications. But there are certain applications where the users of these applications do not want the app to change at all. For example, applications related to money. You don't want the app to change how much money a person has. You don't want an app to change the access that a certain person has to their money. Or let's say ownership. Let's say you have a system that registers the ownership of things in the economy. You don't want the app to be able to change the ownership of who owns what. Long story short, Ethereum is great for applications where the users of these applications need an extremely high level of certainty and predictability over how these applications will behave. The other aspect of Ethereum is Ether. Ethereum has its own native money called Ether. The way it works is this. Any app that gets installed on the Ethereum system cannot ever receive any updates. Once it's installed on the system, it's fixed. The way it behaves is the way it behaves. It will never get an update. In order for people to trigger and launch and run these apps, they need to pay the system in order to launch them. And they pay the system in a native currency that's tightly coupled to the system called Ether, right? Ether, due to how it's designed, has a lot of good properties that classify it as a money, but it also has a utility where it can be used to run apps. So that's an overview of Ethereum and Ether. So now let's jump into that demo. First though, I would like to share 2 definitions in case you don't know. I want to define blockchain and I want to define smart contract. A blockchain is a place where you can store information. It's just like a database. It's a place where you can store information. What makes a blockchain special is that whatever you store in the database, in the blockchain database, cannot ever be changed. In a normal database, you can store information there, but you can also edit or update whatever you store there in the future. In the case of a blockchain, if you choose to store something in a blockchain, once you store it in a blockchain, it can never be changed. So that's blockchain. Now let's define smart contract. A smart contract is a program or app just like any other program or app. The only special thing about a smart contract is that this app or program that they call a smart contract runs on a blockchain. There's nothing smart about it. It's just an app or program like every other app or program, except that it's running on a blockchain. When you take an app or program and run it on a blockchain, they call that a smart contract. There's nothing smart about it. Okay, so finally, I said we were going to start by creating a smart contract and deploying it onto a local blockchain on our computer. In order to do that, I'm going to be using 2 tools, Ganache and Truffle. Ganache is a tool that with one click will create a blockchain that's running on my computer. Check it out. Click. Voila, we have a blockchain. Okay, so now that we have a blockchain, we need to write a smart contract and deploy it onto the blockchain, and then we can test it out to make sure everything's working, right? Truffle is the tool that we'll use to create the smart contracts. Truffle will create all the files and folders that we need on our computer so that we can then jump in and right away start writing smart contracts. Truffle saves a whole bunch of time. here is a gist of what using truffle is like. This is the command that you would write that would cause Truffle to install all of the files and folders that you see over here. After these files and folders are done installing on your computer, you can then come into the contracts folder and start creating smart contracts. All right, I've already written a few here. You can see 1, 2, 3 smart contracts, right? The first one, this one, is used to keep track of whether or not each of the other smart contracts has been shipped to the blockchain or not. This one, the second one, is an example of an ERC20 smart contract, right? An ERC20 smart contract is probably the most popular smart contract that you see nowadays. It's used to create point systems or custom tokens on top of Ethereum. So examples of this would be, for example, Shiba Inu. Shiba Inu is an ERC20 smart contract. Another example would be basic attention token, right? Anyways, there's other applications as well of these types of contracts, but let's not get bogged down by the details. The final smart contract is this one, right? It's a token sale contract. This smart contract creates a storefront on the blockchain that people can use to buy and sell the token that we created in the second smart contract. Okay, so now that we have all our smart contracts written, we need to deploy them onto the blockchain, and then we can test them out to make sure they work, right? This is the command that you use to deploy all the smart contracts that you write in the contracts folder onto the local blockchain. Truffle migrate. Okay, voila. Okay, so let's test everything. Let's make sure our smart contracts actually exist, that they actually do something. So the way that we're going to do that is by using our browser in combination with a tool called Metamask. What does that mean? So at the current moment, browsers don't include the software that's needed by default to talk to blockchain systems. That's not a problem though, because what we can do is install a browser extension into our browsers to extend the capabilities of what our browser can do. And that's what I've done. Metamask is a browser extension you can install into your browser that will give your browser the capabilities to talk to blockchain systems, right? At the top of the Metamask browser extension, we have a drop down that allows us to choose which blockchain we want to connect to. In this video, we're going to be connecting to 3 blockchains, as we said, right? First, our local blockchain. Then we're going to go to the Rinkeby blockchain. And then finally, to the Ethereum Mainnet blockchain, right? So after you choose which blockchain you want to connect to, right? We're still on part 1, so we're connecting to our local blockchain. You then need to tell Metamask which account you own on that blockchain, right? So blockchain systems are just like regular systems with a username and password. Except on a blockchain system, your username is called your address, right? Your password is referred to as your private key. We've chosen our local blockchain. Now let's tell Metamask that we are this user, right? This account. This is how you do it. You come here, you click import account, then paste in your private key. Copy. Paste. There we go. Now Metamask knows about all the assets that this account owns on this blockchain, right? Let's connect Metamask to the current website we're on, right? So that the website can now know who we are on that blockchain. Connect. Yes. Refresh. There we go. Now the website knows who we are. Right? Our address is like our user ID. So now let's try to buy some Zeze tokens. I'm going to try to buy 10 Zeze tokens. And look at that. It went through. Okay, so this is how you tell Metamask about all the assets that you own on a particular chain, right? Metamask wants to know the address of a particular asset on that chain, and it can tell you how much you own of that asset. So this is how you do it. When I deployed the Zeze token smart contract onto this chain using Truffle, Truffle told me what the contract address of the Zeze token smart contract was. And here it is. Copy. Paste. Look at that. Now we can see in Metamask all the assets that we own. Now things are getting interesting. We are done with the local blockchain, and we are now deploying our smart contracts onto the Rinkeby test network, right? This is part 2. What is the Rinkeby test network? The Rinkeby test network is a test version of the Ethereum Mainnet that allows developers to test out their smart contracts without having almost any economic downside. The tokens, or the Ether, that are on the Rinkeby test network are unlimited in supply, meaning that they're practically worthless. Interestingly enough, the app or the website where you get these tokens, these unlimited supply Rinkeby test tokens, has not been functioning for the past week. So I guess maybe this week they have economic value. But that just shows you how clogged, how overloaded the Ethereum network is. This has not been working for a week straight. Luckily, I got some Rinkeby test tokens about a week ago from a friend of mine, and I was able to test everything out and learn what I'm about to show you, right? So here we go. For part 2, we are running our smart contracts on the Rinkeby test network. Part 1 was running our smart contracts on a local blockchain. We're moving up now to the Rinkeby test network. The Rinkeby test network is a network of computers all around the globe that work together to run applications. It's a rough copy of the Ethereum Mainnet. As we said, the Ethereum Mainnet is a collection of computers all around the globe that work together to run apps. So, Infura is a service we can use that keeps track of the addresses of all of these miners on the various Ethereum networks, right? We are only interested in this video about Rinkeby and the mainnet, right? There's others as well, but Infura keeps track of all of the nodes on the Rinkeby test network, right? We can use Infura to send a request, and Infura will dispatch that request out to where it needs to go in the right way, right? And then eventually it'll be received by who it needs to be received by in the Rinkeby test network. Thankfully, with the help of software like Truffle, deploying your smart contracts to the Rinkeby test network is extremely easy. All you have to do is add a few extra configuration lines to the truffle-config file. By default, Truffle is configured to deploy your smart contracts to a local blockchain run by Ganache, but you can add additional configuration for deploying to additional blockchains. Here is my configuration for Rinkeby. You do need one additional dependency for getting the provider field right. The name of that dependency is here. And you just need to provide the API information that Infura gives you, along with an array of private keys for wallet addresses that you own or have access to on the Rinkeby test network. And you can create those by using Metamask, right? You can create accounts on whichever network you want or whichever blockchain you want. And you add them here, and then so this would be the command to deploy your smart contracts to the Rinkeby test network. And after you have successfully done that, you can do a smoke test by checking rinkeby.etherscan.io to verify that your transactions went through, that they actually got mined. And you can do the same smoke test with any app or dApp that you want to test with. And yeah, you just plug Metamask into the Rinkeby test network and test away. Okay, finally, we have arrived at the final step where we will be moving our smart contract code onto the Ethereum Mainnet. This is the Ethereum that everybody knows. I did try to get all 3 smart contracts onto the Ethereum Mainnet, but I only ended up getting 1 on there due to the price implications. The one I got on there was the Zeze token smart contract. It cost me about $340 to get it on there. The proof is in the pudding, so as you can see, I have MetaMask open, and you can see that I own 1 million Zeze tokens. I am a Zeze millionaire. Woo! Okay, so the technique to get it on there is the same technique that we've been using for the other blockchains, the other networks, right? All you have to do is add an additional entry to the truffle config. It's the same technique that you use to get it onto the Rinkeby network. And then you run the same command, right? All you need to do is specify the entry name for the mainnet that you chose. Okay, so I will be selling Zeze tokens for $1 per Zeze. I will be accepting ETH and stablecoins. And this has been a pleasure. Cheers. I'd like to thank 2 people for providing the educational material that allowed me to come to this level of understanding when it comes to Ethereum. The first of those 2 is Andreas Antonopoulos. He wrote this book, Mastering Ethereum. And the second is Greg. I can't find his last name, but his name is Greg, and he has a YouTube channel by the name of Dapp University.